Hi everyone, if you could leave a like and subscribe, I hope you enjoy the video. Good morning, good evening, good afternoon. Today we're going to cover BGP routing protocol. This is going to be part 1 of a series. Today we're just going to cover the basics. BGP is a routing protocol of the internet. It uses TCP port 179 and it has timers set up of 60 seconds and 180 seconds. What we'll do is we'll go through the basic configuration and we'll go through some of the useful show commands and debug. So today's topology, we have autonomous system 111 at the top left with router 1 and 2. 2 is on the edge, and then a link down to R7, which is on autonomous system 333, and then we have R6 at the bottom. Between the routers, we're going to have 192.168.RR, and then R of the router. So we've done this in previous videos. So RR would be lowest router, then second router. So this would be 192.168.1.2.1 on R1 and .2 on R2. And we'll do this the same throughout all the routers. What also we'll have is a loopback IP address of 11.11.11.11, and then R6 will have 66.66.66.66 and R6. So I will configure the routers now and I'll cut to that once I'm done. So now we've configured the IP addresses on all interfaces. I'll just add in the loopback addresses on R1 and R6. So interface loopback 1, IP address 11.11.11.11, 255, 255, 255, 255. And the exact same on R6. Interface loopback 1, IP address 66, 66, 66, 66, 255, 255, 255, 255. To show IP interface brief. You can see there we followed the same format as mentioned earlier, 192.168.67.6 and loopbacks. So with BGP, it's very different from the other routing protocols. There's no multicast IP address, so the neighbors have to be manually configured. And you have two different forms of BGP. You have internal BGP and external BGP. So external BGP is between two autonomous systems, and IBGP is within the same autonomous system. What we'll do is we'll set up EBGP first. This is an administrative distance of 20. So between R2 and R7, let's set up EBGP. So on R2, we'll just set up a capture as well on R2 to R7, just so you can see the traffic. So on R2, we need to do router BGP, and then it's an autonomous system number. So as we said, we're using 111. You have a 2-bit autonomous system and a 4-bit autonomous system. The 2-bit autonomous system, you have a private range which you can use within obviously non-connected internet. So yeah, router BGP autonomous system 111, and then what we do is BGP router ID. And once we've done that, we have to manually set up the neighbor. So it's neighbor, then the IP address of the neighbor, so 192.168.27.7. Then we have to say remote AS and tell this router what autonomous system it's attaching to. So for us, it's going to be 333. So that's us set up the basics of BGP. So on R7, we do the exact same. Router BGP, autonomous system number 333, BGP router ID, then we'll go 7.7.7.7, and then we're going to go neighbor on 192.168.27.2 is on remote AS 111, and then we should see the neighbor pop up. We have an adjacency. So what it is it's formed a TCP connection between R2 and R7 using port 179, as you can see in the packets below. We'll just open this up so you can see it bigger. So you can see we've done a TCP handshake, then from there we've sent an open message, and then we've had an open message from R7 to R2, which we go through what is called open send and open confirm. So the neighbor adjacencies are idle, connect, active, open send, open confirm, and established. And do show IP BGP summary. Just open this up wider. You can see the neighbor adjacency to R2. If we do a debug IP BGP, clear IP BGP. Want to go through the packet process. So if we undebug all, go back to the start. So you can see we've gone from closing to idle. So that's when we've done the reset. Then active went from idle to active. So they're trying to form the TCP connection. Then we've formed the TCP, and then we've gone from active to open sent. So the open is telling the other router what version we're on, what AS is, what our hold timer is. We're receiving an open back from R2, and it's telling us its capabilities. And then once we've decided that we've got the correct AS, so obviously when we say neighbor, IP address, remote AS, autonomous system number, the open that we've got back from that neighbor matches the AS number that we have in our neighbor statement. We have the same timers, we're running the same BGP version, and then from that we have to go from open sent to open confirm. Then we've gone from open confirm to established. So that's us formed up an EBGP neighbor, which has an administrative distance of 20. What we'll do now is we'll set up the IBGP, and then we'll advertise the loopbacks. So we've set up the IBGP, so we'll go to R1 now, and then go router BGP autonomous system, which is 111. Then it's BGP router ID 1.1.1.1. Then we're saying remote AS, neighbor 192.168.12.2, remote AS 111. And then if we go back to R2, we need to do the exact same to him. So neighbor 192.168.12.1, remote AS 111. What tells the router that it's IBGP is obviously we've said router BGP 111, and then when we said the neighbor statement, the remote AS is the same as our autonomous system. So we've had the adjacency to 192.168.12.1 to R1. What we'll do now is we can advertise the loopback. So when we're advertising a route into BGP, the route needs to be exactly the same as the route in the routing table. So the IP address and the subnet mask has to be the exact same. So 11.11.11 mask, then it's 255.255.255.255. And you can see it, there's been update packet because there's been a change. I wonder if we can just open this up just to see if we can see it. So when a router advertises a network, it advertises the IP prefix and the path attributes. So this is called network layer reachability information. So you can see there's the loopback IP address of R1s. If we open that up, you can see the NLRI, prefix length 32, and then the prefix itself. So with BGP, they do not do metric or cost like OSPF or EIGRP. BGP makes its decisions off path attributes. So these path attributes, the best way I can remember them is from INE. The acronym is "We love oranges as oranges make perfect refreshments." Sounds crazy, but I'll put it up on the screen and then we'll show you the path attribute list here. So you can see path attribute, origin, AS path, and next hop. I'll put them up on the screen now of the list of the path attributes. Each path attribute has a different category. So these are well-known transitive, well-known discretionary, optional transitive, optional non-transitive. And I'll put these up on the screen as well so that you can see them. So these are categorized into separate ones. The only path attribute that's different on Cisco is wait, the first one. in the path attributes. This is Cisco proprietary. Weight is also only local to the device. It doesn't get advertised to any of its neighbors. So the list that you've got in front of you, we've got weight, as I mentioned already. Then we've got local preference. So local preference is a value that is used to identify where you want to leave your autonomous system. So when you receive a route, put a default of 100, and when it's advertised to the rest of the network, if the higher the value, the better. So if I had 2 exit points in an autonomous system, and both of them had 2 specific routes that were advertised to me, if one had a higher local preference, I would prefer to go to him to leave the autonomous system to get to that network. So the third one is locally originate, so I prefer to have a locally originated route. Then you have AS path. So AS path is a loop prevention, but also helps to find the best route to. So it's very similar to RIP hop count. So an autonomous system. So if we, for example, the topology we've got here, autonomous system 111, when that leaves the autonomous system, the network layer reachability information is tagged with an autonomous system of 111. If we pull up that Wireshark again, you can see AS path 111. Then if we had it go through our autonomous system 333, and then say if we had another autonomous system 444 further on, then the autonomous system path would add 333 when it sends it out to 444 autonomous system. And then imagine that looped all the way back to autonomous system 111. When the router opens that packet and sees its own autonomous system number, it drops the packet because it knows that it originally came through his own autonomous system number. Then we have origin. So the origin is either IBGP, EBGP, or incomplete. Incomplete means it's been redistributed into BGP. Then you have med, which is metric. So you can assign a metric to the value, similar to all the other routing protocols. Then you have prefer EBGP over IBGP. And then you have router ID, lower router ID. So there is other ones below, which are tiebreakers, but that's from my acronym. That's how I remember majority of them. So now that we've advertised the loopback of R1, on R6 we'll advertise the loopback of R6. So enable config T router BGP 666 network 66.66.66.66, then mask 255, 255. So we'll set up the link between R6 and R7. So config T router BGP 333 neighbor 192.168.67.7 remote AS 333. That should come up. There we go. And then network 66, then mask 255, and then video show IP BGP. So you can see this is the BGP table. If we do a show IP route, you can see we have no BGP routes, even though we have full connectivity between R1 to R6 and obviously R2 to R7. So we're having BGP across all the board, and you can see if we do a show IP BGP, you can see the network 11.11.11.11. So we're receiving the network layer reachability information for that. But can you see the big problem? So when EBGP is advertised, the next hop is 192.168.27.2. But when it's redistributed into IBGP, this cannot be altered unless you put a command in. So if we go to R7 and do a do show IP BGP, you can see it's star and then an arrow. So the arrow means that it's a best route The star means it's valid. So when it means it's valid, that the next hop is reachable. So if we go back to R6, you see that it's a valid entry, but it's not the best route. And then the same is on R1. So show IP BGP. You can see that we have a valid best route to 111. We can see that the 666666, the next hop we don't have a route to, so show IP route to 192.168.27.7. We don't have a route in the table for that. So the way to get around that is on the edge routers of the autonomous system, we need to put in next hop self. So when it advertises it to an IBGP neighbor or peer, it alters the IP address to be itself as the next hop. So on R7, we are in router BGP, which we already are. It's neighbor 192.168.67.6, next hop self. Then on R2, router BGP 111, neighbor 192.168.12.1, next hop self. We go back to R6. What we'll need to do is on R6, we're going to clear the BGP process softly. So this will allow us, the router, to send updates for the BGP so that now these rules are put in place, the route will change. So clear IP BGP, and then we can put 192.168.27.2 and then do soft. So it means it won't tear down, oh, wrong IP address, 67.7. It won't tear down the TCP, it will just reset the neighborship. And you can see now we have it as a best route. That means if we also do R1, so now that's set up, the reason it's not picking is because it's trying to go via the gig01 IP address, so that should work. Yep. Because R1 doesn't know how to get back to 192.168.67.6, because obviously it's not been advertised via BGP, because if you go to show IP route for 192.168.67.6, it doesn't know how to get back to that. So we do a ping to 66.66.66.66, source from 11.11.11.11, works the treat. So if we go back to the show IP BGP, these are some of the show commands. You can see it, network statements for these. The start is, as I said, valid. The arrow is best. The lowercase I at the front indicates that it's an internal. Then the next hop, so the next hop to get to that destination. Metric, so that was the med path attribute we spoke about. Then the local preference, which is 100 by default. Then the weight, if it's a locally originated route, it gives it a 32,768 weight by default. And then obviously when it's advertised, this weight does not leave the router, it is locally significant. Then the path is the autonomous system path. You can see I is for IBGP. It's an origin code, then you've got the autonomous system number. So if we redistributed 66666 into BGP, it would be path 333 question mark. So if we just go to R6, config T, router BGP 333, no network 66, 66, 66, 66, then the mask. So what I've done is put it into OSPF and redistribute it in just for the purpose of this. Then we do a show IP route. As I mentioned, EBGP, you can see that the metric is 0 and then advertised distance is 20. Then for internal IBGP, administrative distance is 200, and then the metric is 0. So if we go to show IP BGP, you can see it's a question mark because it's incomplete, because it doesn't know where it originated from. So if we go to R1 now, you can see 333 question mark. Another useful command is show IP BGP summary. I'll just open this up fuller so you can see it better. You can see there's the router ID, the local AS number, the BGP table version, and then some details about the entries within the tables. Then you've got your neighbor, who you are to, the version at what you're talking, the autonomous system of that router. So I would say it's IBGP, message received and sent, table version, input and output queue, and your up and down. So this is the time that we've been up, and then the state and prefix received. So if we're not established, the state will situate here, but if we're established, then it will have 0 as prefix received. So if I get a network statement from my peer, for example, 1 route, we advertise the 1. And then the other one is show IP BGP neighbors. And you can see there more detailed information about the neighbors that you have. So you can see there's the remote router ID of your BGP, we're established, 1 active. These are the capabilities. So as I said, 4 octets ASN capability, address family IPv4 unicast, enhanced refresher capability. And then you've got here the BGP messages, so open, as we mentioned. Notifications sent when there's an issue between a BGP peer. If I send you a notifications to tell you that I'm tearing down the BGP relationship and the reason why. Updates, obviously, as it says, updates. Keep alives are sent every 60 seconds. We have a hold time of 180 seconds. And then route refresh. And then there's just some more information in regards to neighbors here. You tend to use this command if something's seriously not working. But most of the time, you can get it from the show IP BGP or the IPG summary. And a very good one to use is debug IP BGP. And that kind of tells you sometimes exactly what's wrong, like wrong autonomous system number, or router ID is not unique. So this is the basics of BGP. I hope you've enjoyed. Leave a like and subscribe, and we'll see you next week for another video. Thank you.